All right, we're going to go through the Chapter 9 study guide, and we'll just do it in scrolling order here and not numerical order. But I want you to make sure you take notes and then turn in a copy of this for credit. All right, let's take a look at what we've got here. So if we were taking a test, it would look something like this. Number one, find the first 5 terms of the sequence. Assume that n begins with 1. So I've got a sub n is equal to negative 1n times n minus 3 times n minus 4. Well, I've worked them out down here. A sub 1 is equal to negative 1 to the first power times 1 minus 3 is negative 2 times 1 minus 4 is negative 3. That equals negative 6. A sub 2, negative 1 squared is positive 1. 2 minus 1 is negative 3. 2 minus 4 is negative 2. 1 times negative 1 times negative 2 is a positive 2. A sub 3, negative 1 to the third is negative 1. Well, 3 minus 3 is 0. 3 minus 4 is negative 1. That multiplies through to 0. A sub 4, n equal 4. Negative 1 to the fourth is 1, positive 1. 4 minus 3 is positive 1. 4 minus 4 is 0, so multiplying through, we get a 0 again. For 5, we've got negative 1 to the fifth is negative 1. 5 minus 3 is 2. 5 minus 4 is 1. And this multiplies through to negative 2. So the answer is B, negative 6, 2, 0, 0, negative 2. All right, let's take a look at 3. Determine whether the sequence is arithmetic. Oh, by the way, on number 1, it's neither arithmetic nor geometric, but it is a series, but um, it's a sequence, but it's neither arithmetic nor geometric. Now determine whether this sequence is arithmetic. So does it have a common difference? Well, 11 minus 8 is 3, 14 minus 11 is 3, 17 minus 14 is 3, 20 minus 17 is 3. So yes, it does have a common difference of 3. Right, number 2, find the sum. Well, I could cheat and use my calculator, but I want you to show that you're able to do it the long way. So what do I have? A sub 1 is going to be 3 times 1 minus 2 is 1. A sub 2 would be 6 minus 2 is 4. A sub 3 would be 9 minus 2, which is 7. A sub 4 would be 12 minus 2, which is 10. Oops. A sub 5 would be 15 minus 2, which is 13. Add them up and you get 35. C. All right, so let's find a formula, A sub n, for the arithmetic sequence, where A sub 1 is 2 and the difference D is negative 4. Well, remember that we said our general formula is A sub n is equal to A sub 1 plus n minus 1 times D. So we're going to take the first term and add n minus 1 differences to get our nth term. So my A sub 1 is 2. My difference D is negative 4. So I've got 2 plus n minus 1 times negative 4. So that's 2 plus 6, 4 is equal to 6. And then I've got a negative 4n. So 6 minus 4n. So my answer turns out to be B. All right, find a formula A sub n for the arithmetic sequence where I know A sub 5 is 18 and A sub 8 is 27. I can use this formula here that we learned a couple lessons ago. A sub n is equal to A sub k plus n minus k d. Well, I'll plug in 5 for k and n, 8 for n. And then that gives me A sub n. A sub 8 is 27 equals A sub k, which is 18 plus 3d. That tells me that my difference is 3 because 3d would equal 9, so d is equal to 3. Now plugging this back into my original formula there, A sub n is equal to 18 plus n minus 5 times my difference d, which is 3. So I'm using k is equal to 5 here. Combining like terms, a sub n is equal to 3 plus 3n. Right? Because I've got 18 minus 15, and I've got 3 times n, 3n. Right, number 7, write the nth term of the arithmetic sequence as a function of n. So I've got a sub 1, and I've got a sub k plus 1 is equal to a sub k plus 5. Well, that just tells me that difference, d, is 5. Okay, don't be fooled by these subscripts here. It just means that the next element after a sub k is 5 more than that. So my difference is 5. And my a sub 1 is 8. So I'm just going to use a sub n is equal to a sub 1 plus n minus 1d. Plugging in 8 for a sub 1 and 5 for d. We've got 8 plus 8 minus 5 is 3. I've got 5n. So this combining like terms gives me a sub n is equal to 3 plus 5n. All right, write the first 5 terms of this arithmetic sequence where a sub 1 is negative 6 and d is negative 2. That's pretty easy. Negative 6 minus 2 is negative 8, minus 2 is negative 10, minus 2 is negative 12, minus 2 is negative 14. So that's equal to a. Let's look at 8 here. Find the indicated nth partial sum of the arithmetic sequence. Okay, now I could do this the long way, or I could do it a little bit shorter here. Well, let's first figure out what my term is here. So a sub 1 is equal to 1.4. My difference d is 1.8, and I've got 70 terms, right? So 1.4 plus n minus 1 times d, I could rewrite that as negative 0.4 plus 1.8n. Write it like this. Now I could figure out what that sum is the hard way, or I could use my calculator to do it the easy way and figure out that it's equal to 4445, which is C. All right, 9, find the first 2 terms of the arithmetic sequence are given. Find the indicated term. So I know a sub 1, a sub 2. I want to find a sub 8. Well, this tells me that a sub 1 is 6, and my difference is negative 5. So a sub n is equal to a sub 1 plus n minus 1 times d. So that plugging in a sub 8 is equal to 6 plus 8 minus 1 is 7 times negative 5. A sub 8 is negative 29. Now, if I didn't know that, I could just do it this way. A sub 1 is 6. A sub 2 is 1. Subtracting 5, subtract 5, 5, 5, 5, all the way down to a sub 8, negative 29. Either way would work. Find the indicated partial sum here, n equals 1 to 180 of negative 5n plus 3. The easiest way to do this is just do it on your calculator. All right. We learned how to do it the long way, but we'll just do it on our calculator for now. All right, find the sum of the integers from negative 36 to negative 12. Now, there's a couple ways we could do this. I could, on my calculator, go from n equals negative 36 to negative 12 of n, just add them up, and it equals negative 600. Or I could use this formula, go from negative 36 all the way to negative 12, and then from negative 12 all the way to negative 36, add it up, and this is twice my sum here, because I've got negative 48 25 times, and then divide by 2 is equal to negative 600. Either way would work. Or you could do it the long way and just add them all up individually, but that would take a while. All right. Write the first 5 terms of this geometric sequence. Remember, it's got a common ratio now. A sub 1 is equal to 1. R is equal to 1/10. Well, it's 1. 1 times 1/10 is 1/10 times 1/10 is 1/100th. 1 1,000th, 1 10,000th. So the answer is just simply E. Find the indicated term of the geometric sequence, round to the nearest thousandth. Well, my a sub 1 is -1, my ratio is -1.13, and my n is equal to 9. So remember our formula for a geometric sequence is a sub n is equal to a sub 1 times r to the n minus 1 power. So a sub 9 is going to be -1 times -1.13 to the 8th power, 9 minus 1, and plug it into my calculator, and it comes up to -2.658. Find the sum of the finite geometric sequence. We could do this a number of ways. We could plug it into our formula, or we could plug it into our calculator, or we could just simply add them all up individually. But I think the easiest way is just to do it on our calculators, which turns out to be 2.716 something something something. And if I figure out what the fractional value is, it's 220 divided by 81. All right, number 14, find the indicated nth term of the geometric sequence here. We're going to find the fourth term, so I've got 5, -20, 80. It looks like my ratio is -4. My a sub 1 is 5. I could simply just multiply 80, my third term, by -4 to get -320, which would be my fourth term. Or if I didn't know that, I could use my formula. A sub n is equal to a sub 1 times r to the n minus 1. My a sub 1 was 5. If my n is 4, it's going to be -4 to the 4 minus 1, or the third power, and that turns out to be -320. Either way. All right, use summation notation to write this sum. Okay, now I've got my a sub 1 is 4, my r, it looks like, is 3. We're multiplying by 3 every time. So my a sub n is equal to a sub 1, which is 4 times 3 to the n minus 1 power. Well, I could just simply write out all these terms if I wanted to and figure out which one is the last term. Okay. So it looks like my last term is the 8th power here. So it turns out to be 1, n minus 1 to the 8th, 4 times 3 to the n minus 1. So it's an 8 term, so the answer is going to be C. Yeah, I just did it the long way, just by doing each one individually. All right, number 17, find the sum of the infinite geometric series. Well, we could do it on our calculators, plugging in a large number for infinity. Okay? Or we could do it using the formula either way. And here it turns out to be 21/4. All right, 19. Evaluate using Pascal's triangle. Well, if I just expanded Pascal's triangle like this, I could figure out that that's equal to 126. It's also going to be equal to the same thing as question 18 here. 9c4 is equal to 9 factorial divided by 4 factorial times 5 factorial, and that also equals 126. Either way. All right, number 20 is a little tricky. Use binomial theory to expand and simplify the expression. So I'm going to use Pascal's triangle, the fourth row, 1, 4, 6, 4, 1. I'm going to go in descending order of my x components here. So I've got 3x to the fourth, 3x cubed, 3x squared, 3x, and 3x to the 0 power is just 1. I'm going to go in ascending order for my y term, which is negative y. Negative y to the first is 1, negative y squared, negative y cubed, negative y to the fourth. Add these all together, so that's be 81x to the fourth minus 108x cubed y plus 54 x squared y squared minus 12xy cubed plus y to the fourth. And that turns out to be answer A. We'll skip 21 and 23. Number 22, Find the coefficient A of the term in the expansion of this binomial, 4x minus 3y to the 6th power. I want to find the x cubed y cubed term. Well, this is going to turn out to be the 6th row, the 3rd element. Remember, we're starting from 0, and that Pascal's number is going to be 20. So it's going to be the cubed term here. So my x term is 4x, so 4x cubed. My y term is cubed. My y term is negative 3y. So that's going to be cubed. So it turns out to be 4 cubed times negative 3 cubed times 20 turns out to be negative 34,560 x cubed y cubed. So that's B. All right, we'll skip 24 here. If you want to do it for extra credit, give that a shot. Show me how you did it. All right, 25. A combination lock will open when the right choice of 3 numbers from 1 to 30 is selected. How many different combinations are there? It's simply 30 times 30 times 30, okay, which is 27,000, not 27, 27,000 there. So the answer is E. All right, there are 13 patients in Dr. Ziegler's waiting room. Dr. Ziegler can see 8 patients before lunch. In how many different orders can Dr. Ziegler see 8 of the patients before lunch? So order matters. How many different orders? So we're going to use a permutation. So 13p8, and we're going to use our calculators to figure that out. It's going to be over 51 million ways that he can see his first 8 patients. Quite a lot of different combinations or permutations. All right, skip 26. 28, a bag contains 5 red marbles and 9 yellow marbles. You are asked to draw 3 marbles from a bag without replacement. In how many ways can you draw 2 reds and 1 yellow? Okay, so how many different ways? Well, there are 5 red. There's 5 C2 ways to pick the red, and 9 C1 to pick the yellow. So multiply those two together using your calculator. You can figure out that that's equal to 90. So 180 is wrong there. 29. Determine the sample space for this experiment. 3 marbles are selected from the marbles labeled A through D, where the marbles are not replaced and the order of selection does not matter. So I could have A, B, C. All right. I could have ABD, I could have ACD, I could have BCD. Any of those orders would be a repetition. So like for E here, BCD and DCDB are the same combination. Okay? So there's going to be 4, choose 3 ways. So 4 different ways to do it. So this is the only one that's going to have 4. Okay, and there are 4 unique answers. All right, find the probability for the experiment of tossing a coin 4 times and getting at least 2 heads. Here's your sample space. Well, we know that it's going to be out of 16. Well, how many are at least 2 heads? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them have at least 2 heads. So the answer is 11 out of 16. A. You are given the probability that an event will happen. Find the probability that the event will not happen. Well, if it will happen is given at 28% or 0.28, it's simply 1 minus that. So 1 minus 0.28 would be 0.72 is the probability that it will not happen. All right, we had one on the web assign very similar to this. Find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 3 green, 5 yellow, and 2 red marbles such that the marbles are different colors. Well, I could pick a green and a yellow. There's 3 ways to pick a green, 5 ways to pick a yellow. I could pick a green and a red, 3 ways to pick a green, 2 ways to pick a red. I could pick a yellow and a red. 5 ways to pick a yellow, 2 ways to pick a red. Multiply those all together and divide by, there are 10 ways to pick 2 marbles. It turns out to be 31 out of 45. So the probability of drawing 2 of different colors is 31 out of 45. And that is where we are going to stop for today. So hopefully you were able to get that. If you didn't get all those notes, you can go back and check on the website. All right.